All right, my peeps. So I'm going to literally go over the whole entire assignment that we didn't get through yesterday because of the great alarm, the drill we had. So the first problem, we're introduced to a triathlon, and the biking portion is just part of it, right? So we were just looking at the second part of the triathlon in a bicycle race, okay? And since participants do not start the bicycle race until they complete the swimming portion, the bicyclists have varying starting times, okay? So we know that all of these different people started at different times. That's basically what happened here, okay? And I'm going to zoom in. The graph below shows information about 4 bicyclists during a 20-minute portion of a race. I can't click on this and go on that through paper, so we're going to use this and use the resource page on the back. All right, so take a look. We said that the slowest biker was D, then A or C, because they're going the same speed, and then B is going the fastest. And a lot of you guys said that B is the fastest because how steep it was. You look at the line for B, it starts the latest, but it's catching up to C and D and almost catching up to A. So this guy's like flying through B. The rest of them, they're just kind of going at their own speed. So here, Lydia wants to describe how each bicyclist rate in kilometer per minute for an article in the school paper. To do this, she sketched the triangles. She sketched triangles like the one for line A on the graph below. That's right here. So the question was, where do the 4 and the 6 come from? Well, if you look closely, right, we could count that this is 6 units and 4 units up. And you know where that's going to. That's going towards rise over run for the slope, okay? So you already have this written down, but I'm gonna write it down. So where does the 4 come from? 4 comes from units going up. All right, and that's gonna be called the rise. And the 6, right, is the one, 6 units going towards the right. And that's going to be the run. All right. So the 6 tells us is going 6 on the x-axis. We're saying 6 minutes. 4 is talking about 4 kilometers. So I'll also write that at the bottom. 6 minutes, 4 kilometers. Okay. All right, let's move on. The numbers can be written as a rate in kilometers. This is the learning portion right here, so make sure you're following along. You with me? Yeah. All right, so the numbers can be written in a rate in kilometers per minute to describe the distance the bicyclist rides as time passes. So the fraction 4 over 6 represents how the graph of the line goes up 4 units for every 6 units that goes to the right. The number 4, 6 is called the slope of the line. So slope, we've been talking about slope forever. This is the first time you see it in the textbook. And 4 over 6 is a fraction. So don't be afraid by fractions, okay? And what I'm going to do is I'm going to flip this over and we're going to talk about slope for each of the other lines, okay? So here are the lines, and we already counted this. I'm going to do this really quick. This one's up 2 over 1, 2, 3. Up 2 over 4. Over 4, up 4. Okay? And we could write this. Slope of A is 4 over 6. You can see that the 4 comes from right there. Choose a different color. 6 is right here. Okay? So the 6 and the 4. Dang it, I already wrote these in purple. Whatever, you're good. So this is the rise, 2. And this is the run, 3. You can't tell, that's in pink. All right, so for this is bicyclist C, if you follow along, right? So C is going to be 2 over 3. Let me get my black. Just going to draw my line for all of them. So slope for C is 2 over 3. For B, this line right here, it's 4. Oh, I'm a genius. Good thing that's a darker color. Purple is 4, rise, over the run, which is in pink. So 4 over 4. The last one is going to be up 2, running over 4. All right, we should have this all written down. We're caught up now. So this is where we stopped. Okay, so look at your biking the triathlon research page, blah, 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 right here. Okay, slope can also be thought as a unit rate. So remember that a unit rate compares a change in one quantity to one change or one unit rate change in another quantity. So each time we go up 1 time, 1 minute, how much is it changing by? And that's what we're asking here, okay? So find a unit rate for each of the triathlons by bicyclist, okay? So let's start with A. Slope of A. Okay? And that was 4 over 6. And if we take that slope, 4 over 6, okay, we want to make it over 1. We want to get the bottom number to be over 1. Let me zoom in. Okay, so we want to know what the unit rate is for slope A. So, 7.2.2. So how can we get this number right here to be over 1? Well, we need to divide, I'm going to use, let's see, what's a good color? Divide so what we call the giant 1. We want to divide by 6, okay, to get 1 at the bottom. Well, if we divide the bottom number by 6, we also need to divide the top number by 6, because whenever we divide by 6, that's the same thing as 1, okay? And if we divide by 1, we're going to get the same number. We're not changing 4 over 6. So once we divide by 6 over 6, at the bottom we'll have 1, which is what we want, 1 per 1 minute, right? How many units, how many kilometers is it going? Well, it's going to be 4/6. 4/6 of a kilometer per minute. And we could also reduce that to be 2/3 per 1 minute. So this is kilometers per minute. That's 2/3 kilometers per minute. So it's not even, they're not even going 1 kilometer per minute. They're slow. Okay? So let's keep doing the same thing. Slope of B. I'm gonna write this a little bit smaller. B was 4 over 4. Well, that's gonna be a little bit easier. 4 over, where's my pink? 4. Well, to get 1 at the bottom, we have to divide by, I'll draw this giant 1. 4 over 4, and that gets us 1 over 1. So it's going to be 1 kilometer per minute. Let's try slope of C. C was 2/3. I need to go faster. 2 over 3. And to get 1 at the bottom, we have to divide by 3. So that's going to be 2/3 of a kilometer over 1 minute, which is the same as this guy right here, slope of A, slope of C. They're growing at the same rate. Last but not least, I'm going to turn this to the side. Slope of D, and that's over here, 2 over 4. So I'm going to put 2 rise over the run. And that, my friends, we can divide by, does anyone know, oh, that's an ugly one, what we need to divide the bottom number by to get 1 at the bottom? Nice. It's like Blue's Clues. Do you see the blue clue? Yay! Okay. What do we need to divide the bottom one by? Nice, 4. Okay. Divide the bottom one by 4, you get 1 minute. And 2 divided by 4 is 1/2. So 1/2 of a kilometer per minute. So that's the unit rate for each one of these slopes. Great. Great job, team. All right. Write each bicycle's rate as a decimal rounded to the nearest hundredth. You know what? I'm going to say skip that. We're going to move on. Don't got time for that. Next page. 7-45. While comparing the rates from the problem before, a study team is struggling to decide how to tell which athlete is moving faster. Well, we know the answer to that. The steeper the line, blah, 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 right? So Leo thinks that because, Leo thinks that because athlete A's line is the highest on the graph, he is traveling faster. Well, we already talked about this. Just because he's at the highest doesn't mean that he's the fastest, right? And Kara says, no, you ain't right. Kara disagrees. He starts first, but racer B is moving faster. Now, you could sit there and have a conversation about that. If you want to pause my voice, go ahead. But we've already had a conversation, and we talked about how B is steeper. Yes, it starts later, right? But A started at 6 kilometers and only got to whatever that is, 16 or something. Not 16, probably 17, 18. And B is like flying. He starts 5 minutes later and it's like catching up. Okay? So, what person do you agree with? I wonder. Leo or Kara? Or Kara? Or Kara? Who do you think? All right, I think that's enough time. We agree that Kara is right. Why? Well, the steeper the line, the faster the bicyclist travels. The biker goes. Okie dokie, artichoke. All right, let's look at the next problem. We're at 14 minutes and 15 seconds. All right, here, this is very basic. We have a figure pattern, right? We know that we start with how much? Oh, I can count 1, 2. We start with 2. And how does it grow? So I'm gonna mark the originals. Let me find my green pen. How much does it grow by? How much does it grow by? 1, 2, 3, 4, right? I should have done that in red, but whatever. I'll do it. It's not too late. It's not too late. It's never too late. Never say never. All right. How much? How many? 6. Very good. 6. And it's growing by what? 4. Good job. Right. Now if I take this 1, 2, 3, 4, 5, 6 and I color that in, which I'm going to do in red this time. 1, 2, 3, 4, 5, 6. How much is it growing by? 1, 2, 3, 4. Hey, look at that. It's a growth pattern of 4. How many total? Well, 6 plus 4 is 10. How many do you think there will be here? 14. So on and so forth. Okay? This is not rocket science. This is not new. You've done this before. Okay? Now, here's a graph. Where does this start? Oh, let's take a look. Take a close look. Where do we start? What's my B? Where do I start? Where do I always start? Show me. That's right. That's my y-axis. Where do I start? On my y-axis. All right? Where do I start? What is that? 2. So my B is 2. 0, 2. So my B is 2. 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 Stop wasting time, Mr. Han. Okay. All right. What's the growth rate of this pattern? Well, we already talked about this. It's a growth rate of 4. So 4. How do you tell? Well, let's look at the graph. We go over 1, up what? 1, 2, 3, and 4. Over 1, up 4. Do you see that growth triangle? That's right. Over 1, up 4. Over 1, up 4. Blah, 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 blah. Okay. So we have a growth triangle here. We can see the growth here. We see the growth here. The growth is 4. How can you tell? Because I say so? No. Tile patterns increases by 4. That's a 4. There's one way or another way. Growth triangle increases by 4. All right, what's the slope of the line on the graph? Oh, genius. If I wrote this on my iPad, I'll cut this right here and go. Whoop. How does the value compare to the growth rate of the pattern? They are the same. Move on. Mr. Ragnier's class has been struck with hiccups. 3 of the students track their numbers of hiccups over time. Hiccups. Assume each student hiccups at a constant rate. All right, so in 2 minutes, 8 hiccups, 4 minutes, 16, 7 minutes, 28. Well, you could already see that there's a scale factor here. Are there 7th graders in this room right now? Is there a scale factor right here? It's a scale factor. Times. Nice. They're showing me 4. Just in case you didn't know, I am recording and there's a homework class in my room right now. They're sitting quietly watching me talk to you when you're not here. All right. So there's a scale factor of 4. You could see that it is 4 hiccups per minute, right? If it was 1. All right. This guy, student 2, for every 2 minutes, I'm going to actually write this down. Every 2 minutes, what happens? Well, look at what happens. Every 2 minutes. Noah, what's happening here?
A hiccup.
How many hiccups?
4.
No, here. This one. Look at the screen.
2.
Every 2 minutes, how many hiccups?
7.
Nice. It's growing by 7 every 2. Okay? We'll use the colors I used earlier. 2 minutes, there's 7 hiccups. That is a lot. So how many hiccups per 1 minute? You do the math. All right, here.
3.5.
Nice. Don't tell them.
No.
Shh. Take those words back. All right, here's another growth triangle. But look, it tells you that's 3.8. So every one, oh, look at that. I just got grain on my hand. For every 1 minute, how many hiccups? 3.8. I'll write that down. Every 1 minute, 3.8 hiccups. Well, this one is every 1 minute. How many hiccups? You tell me. I'm not going to tell you. All right. So, which student has the most hiccups per minute? Justify your answer. You answer it. I'm not going to write it down. Find a slope. So, which one will grow the fastest, right? Find a slope that describes the rate of hiccup for each student. Oh, no. Tell me, how much is it going to rise? Right? Over the run. How much is it going to go up and down? For each time it goes to left and right. Right, this one was every 2 minutes, it was 8. Every 2 minutes is 8. Well, every 3 minutes, it's whatever. 12. I want you to fill this one out. If you graph the line, blah, 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 of a line for the student who hiccups 4 times per minute. I wonder who hiccups 4 times per minute. Would the line be steeper, less steep, or the same steepness as the line in the graph for student 2, which is right here? Okay? So, well, if you have the rate for each one, if you have the slope for each one, you could tell me which one's the steepest. And then here's some homework that you guys have to do. 50. There are different slopes. Who's the fastest? Who's the slowest? The last 2 questions. You have 20 more minutes after this. Write the equation. The number of students attending the fall play are 150 fewer than 3 times the number of adults. Number of students. Define my variable. Define my variable. Together, students and adults purchased 1,778 tickets. How many students attended the fall play? This is a system of equation. You need to define your variables. Here, these two are similar, right? You need to solve for x and for y. Look at your notes. When you're done with this, you guys are working on this right here. Nope, that's the wrong one. This right here. See, Ethan, you better have known how to do this because I said you know. All right? You're looking at this. Review systems of equations. So, blah, blah, blah. Sketch 1 system, which means you have 2 graphs or 2 lines that has 1 solution, no solution, infinite math solution. Right here, tell me the POI using equal value method. This one, you can solve for y first, or you can use substitution. When do we have 1 solution, no solution, infinite math solution? How many, are the slopes the same? Are they different? Are the y-intercepts the same? Are they different? That's what I'm asking here. Solve for, this instruction is supposed to say solve for, no, this is a system. Solve for x and y. Find the POI. You could use substitution if you want, or you can use equal value method. Graph these 2 lines, M, B, M, B. Find the POI. Use equal value method. Get this in slope-intercept form. Y equals mx plus b. Tell me what the y-intercept is. Tell me what the slope is, or m. And then here, tell me what b is for an infinite math solution. And if b was 11, what the 2 lines, how would they look if you graphed them? Would they be parallel? Would they cross in 2 places? Blah, blah, blah. All right. Peace out, Girl Scout. Have a good day.